Well, of course, we've been talking about functions, x and y values, and in this little section, we're going to be working on finding function values. But just kind of a little bit as a review, of course, we have x values and different names that we may use for that x value might be the input value, the independent variable, the domain. Any of those terms may be used. Typically, maybe we'll probably be with x and domain, but and then y values and other names that we might be using for the y values might be output value or dependent variable, the range. And as it pertains to functions themselves, we'll see how that we'll use something that is called f of x. But the big thing to remember, of course, for something to be a function, there has to be exactly one value for y for each x value. So in other words, an x value can only have exactly one value of y. And of course, we looked at vertical line test as how if we're looking at a graph, and also identified functions by tables as well as mapping, and then of course ordered pair. So let's kind of proceed, and we're going to move on and talk about finding function values. So when we're talking about functions, equations that are functions can be written in the form of something that's called function notation. So, I mean, if we've got an equation, let's say we've got an equation that is y equals 3x minus 8. Well, if we put that in function notation, it's f of x, f parentheses x, we read that as f of x equals 3x minus 8. So you may recall we actually played a little video song the other day in class. F of x equals 1y. F of x equals 1y. Okay, enough of that. Anyway, we substitute in f of x for y. Now, in a function, x represents the elements of the domain. So x domain, x independent variable, x input value. X represents the elements of the domain, and f of x equals 1y, f of x, okay. F of x represents the elements of the range. So we are getting ready to find function values. Now, before we actually get into some calculations, let's just go over a couple of other things. So if we wanted to find the value in the range, this is y, or f of x, that corresponds to the element 5 in the domain, x is equal to 5. What is the value of the range? What is the f of x value if x itself is 5 in this function equation or function notation? Then what we would do is we would find the value of f of 5. Again, if we see f parentheses 5, that's read as f of 5. And we would find the value of f of 5 by substituting in 5 for x in the equation. This is how we go about finding function values. Okay, I keep teasing you that we're going to take a look at finding function values, but there's just one more thing. A function with a graph that is not a straight line is a nonlinear function. Let me say this too. If we input the function equation into a calculator and then go to the graph, and we'll be looking at that as well, then we'll see what the appearance of that graph is. And what that calculator is doing at that point, it's trying to calculate every possible value of x and what y would equal, and then it plots that on the graph. But what we're getting ready to do, we're going to take a look at just specific x values and how we find what the function value is, or what the range is, or what y is when x is equal to a certain value. And sometimes it'll be a straight line. That's something we call a linear function. And then we may have things that are not straight lines. And so we have things like quadratic functions and cubic functions and square root functions and reciprocal functions and absolute value functions and greatest integer functions and constant functions. Oh, there's quite a list. Have fun. Okay, so let's look at finding some function values. And I'm on page 50 in our book. This is example 4, and I'm looking at the guided practice. And so we're given a function equation, f of x equals 2x minus 3. And then we're asked to find, okay, well, what is f of 1? So when x is equal to 1, what is f of x or y going to equal? And all we're going to do is substitute in for an x this value of 1, and then we're going to solve that. So 2 times 1, of course, is 2. So then we got 2 minus 3. And so when x is 1, f of x or y is minus 1. And this next one's a little bit trickier. I'm going to come up here to the top. So we've got 6 minus f of 5. So okay, well, we got 6 minus f of 5. So what we have to do here is we're still going to have our function equation right here of 2x minus 3, but we are going to first put a 6 in front of that, 6 minus, and let's put in parentheses our function equation, 2, and I'm going to substitute in 5 for that x, 2 times 5 minus 3, let's close our parentheses. Now we're going to solve. So I got 6 minus, I'm going to go ahead and multiply 2 times 5, that's 10, minus 3. And so 6 minus 10 minus 3 is 7. So I got 6 minus 7. Well, guess what? That's also minus 1. So when x is 5, y is also minus 1 in what we've been asked to solve here, which was 6 minus the function equation 2x minus 3. Let's see if we can get another one in here, one that's not quite as weird as that. Let's say we're being asked to find what is f of minus 2. Minus 2. So here we go. We're going to plug this back into our function equation. All right. Of 2x minus 3, I'm going to put in 2 times minus 2 minus 3. And 2 times minus 2 is minus 4. Minus 4 minus 3 equals minus 7. So when x is minus 2, well, f of x or y is equal to minus 7. Now, I got one that's a little bit more complex than that. We're going to save it for another slide. Let me move to the next slide, please. Okay, so we're still going to be working with this same f of x equals 2x minus 3 as our function notation or our function equation. But let's say that we're asked now to find something like this, where we're asked to find, well, okay, what if we got the f of 1 plus f of 2? Okay. Now, all we're going to do, and what we're actually doing here, is we are now going to be plugging in minus 1 in this 2x minus 3, and then add that to f of 2, substituting in 2 for the x. And so let me just kind of go through and we'll see how this works out and demonstrates. So I'm going to go ahead and set up my equation. And so I'm going to say here that I've now got, I'm going to put this in parentheses, make it easier for me to see and solve. I'm going to go 2 minus 1. This is where the f of 1 comes in, minus 3, close my parentheses, plus parentheses 2 times f of 2, or substituting in 2 here for this x, minus 3. Now, of course, obviously, we got to do order of operations here, so we got to solve what's in here first. So 2 times minus 1 is minus 2 minus 3, plus 2 times 2 is 4 minus 3. And now let's add and subtract left to right. So minus 2 minus 3 is minus 5, plus 4 minus 3 is 1. Okay, so I got minus 5 plus 1, and then I can say then here that f of minus 1 plus f of 2 is going to give me minus 4. Bingo, bango, bongo, done. All right, we'll look at one more little example here, and then we'll close this out and get us on some working some problems ourselves. All right, now remember now math, Isaiah 28:10, precept upon precept, precept upon precept, line upon line, line upon line, here a little, there a little. That's what we do in math. We just kind of keep building on precepts and concepts. So let's say I'm going to go this one here. I'm going to do two more examples. So this one and then one more. Let's say that we've got f of x. F of x equals 6x plus 7. Let's say that this is our function notation or our function equation. And this time we're asked to find f of r minus 2. So this is a little bit different. We're building on our concepts. And so what I'm going to have to do here is in place of this x, I'm going to have 6 times r minus 2. I'm substituting the r minus 2 for the x plus 7. Then I've got to solve. Well, if you remember back now, we've got distributive property. And so I'm going to distribute this 6 over the r minus 2. And so I'm going to have 6r minus 12. Don't forget now, I've got to distribute the 6 to both terms inside that parentheses. 6r minus 12 plus 7. Okay, well, I can still combine like terms. I've got this minus 12 plus 7, and so I can come in here with 6r minus 5. Are you picking up what I'm putting down? Are you picking up what I'm putting down? I know you are. All right, let's look at one little different wrinkle here. Let's say this time what we've got is actually two function notations or function equations. And one of those is with the same one we used before, which was 6x plus 7. Let's say that we've got a second function notation, g of x, where g of x equals x squared minus 4. And now we're asked to solve something like this, where find what the value is of f of 2 plus g of 2. Oh no, what are we going to do? Well, we're going to substitute 2 in for f of x. So let's do this. We got 6 times 2 plus 7. And now we're going to add g of 2 in this function notation of, I'm going to substitute this in. So we got 2 squared minus 4. Okay? So let's solve. Okay, I'm going to work inside each of both parentheses. So 6 times 2 is 12. So I got 12 plus 7 on this side. Plus, well, 2 squared is 4. And I got 4 minus 4. Let's keep going. 12 plus 7 is 19, I believe. Plus, well, 4 minus 4. 0. Not too bad. And 19 plus 0 equals, of course, we know this to be 19. Okay, so this is where we added two separate functions together. And precept upon precept, line upon line. And we are done.